Hello students, this second video will talk you through another example of how we would construct a voltaic cell. So what I would like to do is emphasize this reaction, which is on the very first page of your first Electrochem packet. You're actually provided the entire balanced reaction. All of the ion charges are labeled. However, for permanganate, remember the majority of the time, oxygen is given an oxidation state of -2. To have the -1 charge left over for this polyatomic ion, we need manganese to have a +7 charge. So if we examine this further, the manganese is going from +7 to +2. It is gaining electrons, and of course it is going through the reduction, because we're going and becoming less positive, if you will. Now remember, manganese is what is undergoing the reduction, but the permanganate ion is what is the oxidizing agent, what is responsible for causing the oxidation. Where if we look at the iron, it is going from +2 to +3. It is losing electrons, so it's going through the oxidation, and the iron +2 ion is the reducing agent. So if we want to, examine this further, how can we exactly tap into the transfer of electrons from the iron to the permanganate? Well, if we can separate the oxidation, iron +2, to the iron +3, and the reduction, and we have the permanganate ion creating manganese +2. So, as with common diagramming, I like to always place the oxidation on the left. And so I'm going to go ahead and choose for it to be a beaker. And inside of this beaker, my oxidation reaction is all ions. So I need to show that I have those there. And I probably have created a solution by adding iron 2 nitrate and iron 3 nitrate. The nitrate ions would be spectators, and it would have provided the iron +2 and iron +3. Now, if there is not a solid that is part of the full oxidation, this reaction will not work, because we need a solid to which the iron +2 can collect upon and give the electron to, creating the iron +3. So, we need a solid, and the majority of the time, we are going to choose platinum. Platinum is an inert metal, so it can conduct the electron, but it itself will not partake in any kind of reaction. Another very common material for solid electrodes would be graphite, but let's go ahead and choose platinum. So I would either need to identify it's platinum or point to it being platinum. So usually what we'll do is label the electrode to be platinum. What I'll need separated in another beaker would be my entire reduction, which would be the permanganate and the manganese ion. And I've probably added potassium permanganate in some concentration, and maybe manganese nitrate. Now notice also we just have ions, and so we need to have solid, and let's go ahead and choose a platinum electrode also. And we know these are going to need to be in contact with each other through a wire, and we're probably running this wire through something to get the electron to do work for us, let's say a light bulb. It could also be run through some kind of voltmeter that could be measuring the voltage that is running across this. We also need a salt bridge, and we need to be labeling this. And again, the salt bridge will be, usually it's kind of a porous material, probably cotton, that has absorbed sodium chloride or some other ionic dissociated compound in solution that will maintain electric neutrality but does not partake in the reaction. One more thing, we need to make sure that we've included everything for a balanced reaction. Now, of course, we have water present in both of these because of our aqueous solutions. But what about this hydrogen ion? Well, let's go back into our half reactions. Remember when we were balancing half reactions, we would count the number of each element other than hydrogen and oxygen. And we have one iron ion, one iron ion. We're good to go. So the only thing we'd need is to balance charge, if we needed that here. But what about here? We have one manganese, but 4 oxygen. And remember, to balance oxygen, we would add that same number of water. But then we have 8 hydrogen. So to balance hydrogen ion, we would add hydrogen on the left. So my hydrogen is needed in the reduction. So I need to put my hydrogen ion there. Here's my oxidation, my reduction. Only one more thing, showing the path of electron flow. Remember, the loss of electrons is happening in the oxidation. So the electrons will be flowing in this direction. There's only one other thing to label. So on the next page in your packet, it talks about anode and cathode. Anode is the cell in which oxidation occurs. And the cathode is where reduction occurs. And I know this is quite silly and cheesy, but I always remember we have val and val. Anode, oxidation, and consonant, cathode, reduction. So, going back to our cell animation, we could say oxidation, but this is where the anode is, where the oxidation occurs, and cathode, and the electrons will flow from the anode to the cathode. That is it for the end of the diagramming of a basic voltaic cell.